Remind me what we talked about yesterday and the day before. So really, how many days did we spend on that? Really 1 day, right? Okay. Really 1 day because more than half of you were gone for PSAT yesterday, right? Okay. So, why in the world would we spend 1 day on 3 operations and then spend 2 days on division? Have you done addition, subtraction, and multiplication before? So that was just 1 day of review, right? Have you ever done division before? No, so this is brand new stuff. So do you see why? Does that automatically mean division is harder? No, it does not. Okay? So you've not done a problem like this before, have you? So then let's talk about this one first. Why would we talk about this one first? Yeah, you've done it before, right? Do you think maybe it might be similar? Whoa, okay. So what goes where? How do we do this problem? We have to draw one of those, right? What do you guys call that? So last period called it the house, and the period before that called it the elbow. It does have a name. It is a division sign. It actually has a name besides that. I don't want to blow your mind today, so I'm not going to tell you today. Yeah, you can search it up by your own self. You have a computer literally right in front of you. Okay, does everybody understand? I mean, it doesn't really have anything to do with understanding. You just know this, right? Okay, so what step do I do first? So how many times does 18 go into 3? It doesn't, right? So I need to add the next term, right? So how many times does 18 go into 34? Once. So where do I put the 1? Above the 4, because that's the number that it went into, right? The 34. Now what do I do? What do I do first? So where did I get 18? 1 times 18, right? I multiply these two, and I get 18. And then you subtract. Notice I used a different color. Okay? You'll see why in a little bit, I hope. So what's 34 minus 18? 16. And then what? You bring down the 7, the next term, right? Now what? We just start over, right? How many times does 18 go into 167? 9. Good. Now what? Multiply, right? 9 times 18. What is 9 times 18? 162. And now? Subtract. What's 167 minus 162? 5. And now? Bring down the 2. Is this hard or easy? Like so easy that I'm just saying and now, because you already know what to do, right? Okay, so 52 divided by 18. 2, right? 2 times 18. 36. And subtract. And you get 16. What would you do now? You'd put a decimal here and add some zeros, right? We don't want to do that. I wanted to know how many times 18 went into 3,472, right? So I got 192, but I also have this. What is this? The remainder, right? That's the remainder. So if I'm writing an answer, I would write 192. Now, when you did this a long time ago, you probably put a little r right here and then 16. No. We're not doing that because, again, we're more mature mathematicians now. It was fine for back then. It was fine. That's what you needed back then. Now we need to understand what's happening here. This is 192 and 16/18. This is my remainder over what I was originally dividing by. Right? Do you have any questions about that? You've done that for a while now, haven't you? Now, most of you actually probably do it this way, right? But you have done this before, haven't you? And it was important to walk you through the steps because now our problems look like this. And you already know how to do it. Because guess how we set it up? What goes on the outside? X minus 1. What goes on the inside? What did we do? Yeah, this way is even easier because I just look at these two. How many times does x go into x cubed? Another way to think of it is what is x cubed divided by x? Isn't this same as x cubed divided by x? What's left? X squared, right? Wait, you keep that in your mouth for a second. We're going to put it out. We're going to pull it out in just a second. Okay? What's the answer? And where does it go? Top where? Above the x squared, right? Wouldn't we put it with its like terms? Wouldn't that make sense? Okay. What do I do now? What did I do with the 1 and the 18? I multiplied it, right? What do I do with the x squared and the x minus 1? Multiply. What's x squared times x? X cubed. What's x squared times negative 1? Negative x squared. Now what? Subtract. Okay? If I put the subtraction sign here, am I going to remember to subtract this one? Am I going to remember to subtract this one? Probably not. Okay? So I'm going to subtract each term. Why in the world did I make that positive? It was already negative. And if I subtract a negative, what's happening? It's positive, right? So what goes here? 0. What happens here? Oh, nice. Also 0, right? So what do? So here's what I want to do. I want to bring all of the rest of it down. No matter what's there, I bring the rest of it down. Because I'm going to need it eventually, right? I didn't bring the rest of it down here because it would have been distracting to have 1,672 when I just needed 176. Or excuse me, 167, right? Here, because of how we're doing this, I want all of the rest of it down. Got it? Now I start over. What's this term divided by this term? Negative 2x divided by x. Negative 2. Where does it go? Above the 8. Why would it go above the 8? Like terms, right? Negative 2 times x. Negative 2x. Negative 2 times negative 1. How about plus 2? Is that all right? And now, what? Subtract. Somebody earlier said, it looks like you're just changing the signs and adding. Is that kind of what I'm doing? Isn't that what subtracting is? Right? So I told them if they wanted to think of it as changing the signs and adding, I guess that's okay, but what we're doing is subtracting. You okay with that? What's this? What's this? Now what? Guys, is there anywhere else to put answers at the top? So once you put your answer over your constant, once you put your constant over your constant, you know there's no more dividing that's going to happen, right? Now, that's not always the last place that it goes. It might go here because of what we're dividing by and nothing's going to be here. But once I put a constant over a constant, I know there's no more dividing. Okay? Because think of this. 6 divided by x. Can you do that? You can't simplify it, can you? Okay? So we don't have that. So what's my answer? So x squared minus 2 plus what? 6 over x minus 1. Perfect. Got it? Any questions? Can we do another? Okay. Please, that was so polite. Thank you for that. Please, please, let's do another. All right, what goes where? Okay, inside. All right, x cubed plus 7x squared plus 10x minus 6. Okay, x squared plus 4x minus 2. Where do we start? So divide the first term by the first term. What do you get? X cubed divided by x squared. So at least one of you has seen the rule. And we're not having to do this every time, right? When we're dividing like bases, what are we doing with the exponents? Subtracting. Does that make sense? When we multiply like bases, what do we do with the exponents? Add. So does it make sense that if we're dividing like bases, we would subtract the exponents? Excellent. What's x times x squared? X cubed. What's x times 4x? 4x squared. What is x times negative 2? Negative 2x. And now? Subtract. Subtract each term. What do you get here? Will we always get a 0 here? If you've done it right, that was the whole purpose of dividing this by this, right? To get this. So once we multiply these two and subtract it, it should be 0, right? If you get anything besides 0 here, something's wrong. Okay? Does that make sense? So this is 0. What's this? 3x squared. What's this? 12x. And then bring down the 6. Well, the minus 6, right? Now what? Start over, right? 3x squared divided by x squared. So 3. Oop, it's going over the constant, right? So am I going to have to do any dividing anymore? Okay. So 3 times x squared. 3x squared. 3 times 4x. 12x. 3 times negative 2. And now? Well, look at that. What just happened? So there's some vocabulary I'm going to need for you to have next week, and I would like to start using it today so you're familiar. You okay with that? If you're not okay with it, I'm still going to do it anyways. Okay, just so we're sure. When you take a polynomial and you divide it by a polynomial and you get a remainder of 0, both what you divided by and your answer are factors of this original polynomial. Okay? Take a polynomial, divide it by something, and get a remainder of 0. Both of these two polynomials are factors of the original polynomial. It only happens, that's only true when the remainder is 0. You got it? Any questions about this problem? Do you mind if we do one more? Okay? Well, I mean, I have to try to trick you, right? Oh, you don't want me to try to trick you? Okay, well, there's a couple like this on your homework, so I'll just let you go ahead and start. Oh, you might as well do it since I already have it written down for you. All right. You wouldn't want to waste my ink on my pen, right? Okay. So what goes where? So x squared minus x plus 1 goes on the outside. What goes on the inside? See, I tricked you. On all these, there's a decreasing x value every time for the exponent. Excuse me, not x value, but exponent, right? 4,